Let's work on some problems involving logarithms. Solve log base 3 of x equals 5. When you look at this problem, all we actually really need to use is the definition of a logarithm and we'll be done. Because by the definition of a logarithm, our base, which is 3, and our exponent is 5, gives us x equals 3 to the 5th. And that's the same thing as 243. So we have log base 3 of x equals 5 gives us x equals 243. Let's move on to the next problem. Solve log base x of 49 equals 2. So looking at this, we get x squared equals 49 based upon our definition of the logarithm. So with x squared equals 49, we also need to remember our base, which in this case is x, has to be a positive number. And it can equal 1 is the other case, but we don't have to worry. It's not going to equal 1 since we don't have x squared equals 1 here. So what we end up finding is that we can take the square root of both sides and just worry about the positive version. So you get x equals the square root of 49, and that actually equals 7. Let's take a look at our third problem. Evaluate the log base 5 of 625. So in order to do this, we don't have an extra exponent to get involved just yet, so we actually do that by putting in a placeholder variable we'll call y. So we'll say y equals log base 5 of 625. What does this mean? The equivalent exponential equation would be 5 to the y equals 625. So now our purpose is to write 625 as 5 to some power, if at all possible. And it is. If you notice, 5 squared is 25, 5 cubed is 125, and 5 to the 4th power is actually 625. So that means that we have y equals 4, since these equations are 1 to 1, and we have our answer of log base 5 of 625 equals 4. Moving on to the fourth problem. What is the domain and range of the function f of x equals natural log of x? So this is one of our common logarithms, and it might be a little more familiar if we write it as log base e of x. So instead of writing f of x equals natural log of x, we rewrite it as f of x equals the log base e of x. And now we need to recall from the original function when we created the logarithm that this has a domain and range given by any b value that you have down below that's positive and not equal to 1 has a domain of 0 to infinity and a range of all real numbers, or negative infinity to positive infinity. So what does this mean? Well, b satisfies those e actually satisfies those conditions given for b. So that means it should have the same domain and range. So in our case, we have log base e of x, or natural log of x, that has domain 0 to infinity and range negative infinity to positive infinity, or range of all real numbers. And if you take a look at our graph, we can see that illustrated here. Notice the x values never quite touch that y-axis, meaning x is always greater than 0, and our range seems to extend. It keeps on going up and up and up. Okay, moving on to our next problem. Evaluate the log of 8,675,309 of 1. Now, usually we'd go y equals, and we can do that. But we can recall that from property 1 in logarithms, we actually have, for any b satisfying our conditions for a base of a logarithm, log base b of 1 always equals 0. So it doesn't matter what happens as long as 8675309 satisfies those conditions, which it does. We have that the log of 8,675,309 of 1 equals 0.